how those variable names have nothing to do with how you call it. They're just for use inside the function. And everything else inside the function is completely irrelevant to anything else outside the function. None of the variables creep in, or whatever you want to call it, right? So it's as if it's all self-contained. That function knows nothing about anything else in the file, or other files, or whatever. So you write it in such a way that it doesn't need to know anything except those things in its parameter list, those few things that you want to tell it from the person, the routine that's calling it. And that's both the beauty and the pain of functions. The whole idea behind a function is that it's a self-contained little hunk of code that just does one thing. And it only needs a few things to be able to do that and provide you an answer. So you don't have to think about the rest of your program to write this one little function. And you try not to. Try not to think of everything else that you need. Just try to think about what this one function needs to do. Because if you try to think of the entire program all at the same time, your head will explode, right? It's not possible. So, function by function. And then you build up other functions, function calls, other functions, and those function calls, and then you end up making a whole program. So,
it's pretty comparable. We played the Wii Fit over the weekend with my 11-year-old.
yeah.
And I couldn't help but think about this stuff. You know, like you have your main characters, and you know, it says you did a great job, or you're in 10th place, or it's. So I was thinking, you know, how would I can't imagine writing a program for.
Sure.
That's why it probably took them years and years. But it's brilliant. What they did was, it's amazing. You have this little control thing over here, and it takes your movements, and I was thinking,
yeah.
you know, to program all that, you know, what they would have to know, and then write, and then, you know, to pull this together
yeah.
to do that.
Not to
But,
mention they got
my gosh.
teams of people doing it, right?
Yeah. Yeah, like just on the A button itself to make it go back to the menu or whatever.
Yeah.
Like everything, single thing that she used.
Yeah.
It was. It makes you think about these kind of things. Like, oh my gosh, what's this? To be good enough to do that.
And really.
And I can't even.
And all it comes down to coming up with this complex of a program. All it comes down to is defining what every function needs to do, and then writing it, and then calling them in the right order, and you're done. That is programming. And you thousands of functions, I imagine. They farm them out to a bunch of people.
I was thinking, just even, you know, if you're bouncing the ball in the air, that's a function, and as you're stepping along to the band music, that's a, you know, to pull. Yeah, I was thinking, I'm so glad there's people out there that do that, because I certainly would never be able to pull that off.
I often like to compare programming to cooking, following a recipe when you're cooking or making a cake or something, right? There's a bunch of steps you got to go through in order, and when you're done, you've got a cake.
So you can't focus on the whole thing.
And each step is like a function in a program. And maybe some of those have sub-steps, other functions inside that function and stuff. So we'll actually, one of these days, keep meaning to get to it, not yet. We're actually going to go through program design and talk about recipes. And we're going to program a recipe in C. Because you can do it, assuming you have a robot you can control. That's us, right?
Yeah.
And I'm going to go through how to think about how to do this, because we're all pretty good at we're all pretty good at driving, right? We can drive. So we can follow step by step, start the car, put it in gear, hit the gas, turn, stop at the stop signs, hopefully, various things like that. Each one of those has a function. And then the path you're following, maybe that's some data structure of some kind that says when to do what. And away you go. And so even driving is comparable to a simple program with a bunch of functions. And everybody's job is also comparable to a program with a bunch of functions. And you've got accounts to deal with, you've got applications that are either complete or not, and you got to yell at them and give you what's missing. Each one of these is just following a bunch of steps, perhaps not in the same order, but whatever. Even programs, you can program to do it in kind of whatever order makes sense, not necessarily a certain order. So you can, for example, for yours, you've got a bunch of variables to keep track of whether each of the pieces of that application are done or not done, 0 or 1. Bunch of integers, and you can have a program that goes and looks through each one of these, and the first one it comes to that isn't done makes an email, yells at the guy that, where the heck is it, and then just keep going. So everything you can think of in a program. Now, you may not be following it quite that way in your own head, but you can think of it that way, and you can think of any program you're writing as similar to the jobs you do, and all the steps and all the pieces and all the data that goes into it. And it's just a little bit more formal, a little bit more pain in the neck than the syntax and all, than doing it for real. But then once you've programmed it in the computer, you can hit return instead of actually doing the work. So that's the beauty of programming. It does the work for you.
You hope.
Yes, that's the hope, and of course it never really works out that way. But so good. I don't think we're going to wait for Carla, but heck of it. All right, so we're going over functions again. So remember, it's similar to how you do ifs and whiles. You've got some thing up front, you've got some parens, and then you've got some enclosed code, just like ifs and whiles. Unlike ifs and whiles, stuff in here, there can be a bunch of stuff in this one thing that they have. And each one has a type and a variable name. Type and a variable name is however many you need. And we've also got this return type, which usually is an answer or something like that. And so each of these variables here is as if you declared it right here, so that you can use it in all this code. So the curly braces, they're enclosing all this code. It could be one line, it could be a zillion lines. And you have to have a return type, even if you're not returning anything. But in all the ones we're doing right now, we're always going to return something. And this name has to be unique, so that if you're going to have a variable name in like your main program, it better be different than this. And I'll show you a lot of examples of that. But sometimes it's a pain in the neck. You come up with this idea, some concept, like tax rate. And it makes sense that this thing is called tax rate, so it will calculate the tax rate for you. But it also makes sense that you have a variable in your main program called tax rate. So it's sometimes a pain in the neck to come up with these two different names that are different but kind of mean the same thing. And so these arguments are very important, and without those, the thing only does one thing and it's kind of pointless. So this makes it calculate different values for the different ones. And then return statement. So you'll notice that syntax is exactly the same as the syntax we use to define name. int, main, parens, there's nothing in there. Begin curly brace, end curly brace. So main is a function, just like any other function, except it has a very special name. And it has this special name because the operating system, Unix or Linux or Windows or whoever, when you run a program, it's actually calling main when it runs the program. So it calls that function to make your program run. And so it needs something to call it. So it calls main, and you have to call it main, otherwise it can execute. So you look confused.
Yeah, I'm just trying to take it all in and organize the steps in my mind.
And admittedly, I mean, we don't talk much about the operating system here. But every time you type in the name of an executable, the operating system calls main inside that file. That's how it knows to run the program.
Basically, everything you do will always start with main.
Always.
No ifs, ands, whiles, or buts about.
That's right. Always. Yeah. Okay. So you'll notice you've used this printf and scanf before, and each one of those you enclose all the arguments in these parens. So to see, when you have a name with parens after it, think so that's a function call. Except for if and while, which it knows are special, and you better not have a function named if or while. Don't do that. Except for those, it knows that, okay, that's a function call. So it does function call stuff when it does it, right? And this is different than what it does for like expressions, like A plus B or whatever else. So function calls are special, and it knows that they're there because it's got this paren. Curly braces in C almost always mean we're going to enclose code in some way. So like after the S, after a while, and after the beginning of this function call. So curly braces are always used to enclose code. Parens are always used to signal that we've got a function here of some kind and we're going to enclose parameters. So this is a really simple thing. I mean, the compiler is really, really dumb. Okay? It's dumber than my cat at home. It doesn't know crap. So it sees this and it says, okay, it's a function. And it's about as simple as that. Not quite, but almost. And if it sees, the beginning curly braces, it says, okay, it's the beginning of a bunch of code that I better put together into something. So syntax is really important. It depends on the syntax in order to do the right thing, because it's really dumb. There is no meaning. It doesn't really ever get meaning. It's just compiling. It's really dumb. And every program you write is just as dumb, perhaps dumber than the compiler. And for example, you depend on numbers being written a certain way when you do this thing, when you're trying to read in a number. This thing knows numbers are always written a certain way, and there's no semicolons in them, for example. There's no vertical bar. There's none of these weird characters in numbers. So it knows what a number should look like based on characters. And so the moment it sees a character and it doesn't belong in a number, it stops trying to scan and says, okay, that's the end of the number. See what I got, let's turn that into a number. So programs are really, really dumb. All they can do is look at characters and try to make sense out of it. And printf doesn't do that, it's just print stuff. But scanf and compilers, they have to kind of look at all this junk that we're typing in and do the right thing. And it's very difficult to write a program to deal with that. And so us writing code that doesn't confuse it is important. And later on you'll see that when you're reading files, you're reading information out of files, like say a spreadsheet. If it says undergrad with a capital U, and your program is expecting undergrad with a lowercase u, it will fail. Not the right thing. It's a different character. And unless you write your code to be smart, deal with such issues in some way, it won't be able to. So a lot of what we're dealing with when we're writing code is dealing with the stupidity of code and making it so that it can handle as many dumb things that we do as we can. So anyway, just to remind you, remember when we first defined our own functions, we had to actually declare it before main used it. And for printf and scanf, we didn't declare it, right? Because they're actually declared somewhere else. And remember, we have this, where is it? This thing right here. In every program we've ever written so far, we have this line before main. What the heck is this doing? The idea is that somehow we need to include the definitions of printf and scanf before we do our main. But we don't know what those definitions are, and we didn't write them. So somebody else wrote them, and it's part of this thing called the C standard library, so that we don't have to write them. Everybody uses them. So they wrote them once, and everybody uses them. And the compiler already knows all about those functions. But when it's going through your code, it still needs to have the definition in your file in order to be able to compile it. So this thing right here, the include, this pound sign here, what order am I doing this in? So the vague overview is that this line makes it so that the compiler knows the definitions of printf and scanf. Somehow this makes that happen. The way it works is that when the compiler runs, the first thing it does is it calls something called, it's another program. So actually running the compiler itself runs several different programs to actually do the compiling, and it runs in order. First thing that it runs is something called a preprocessor. Preprocessor does all kinds of things, but in this case all we care about is that this pound sign tells the preprocessor that this is a preprocessor command, and the command is include, and the argument is this thing. So it's telling the preprocessor to include a bunch of stuff from a file named standardio.h. And not studio. It's short for standard.io. Standard input output, so reading and writing junk. And these angle brackets tell the preprocessor, again, we're talking to a program, it tells the preprocessor that this file is somewhere in the system directories, which I haven't talked about yet. But it's not a file that you wrote. It's a file that they wrote. So it says use their file. And what it does is it grabs this file is filled with C code. It says grab that file and shove it right there into my code, as if it was all just in there instead of this include statement. So now what it does, it actually changes your program. But of course it's its own version of it. So it's got a file with your program in it, and when it's done with that, now it's got a bigger file with all that other junk in it too. Then it takes that file and it gives that to the compiler. So the preprocessor runs before the rest of the compiler does, and it messes with your file, and then it gives it to the compiler. So, right. So now it's got all those definitions that are included in standard IO.H. In particular, the ones we're using for scanf all the time. So it's got those. And at the moment, we don't know enough to actually read these definitions and make sense out of them. So it's good that we're not doing it. But it works. So now it knows what they are. If you were to try compiling one of your programs, say the demands of the program, and you didn't have include standard IO.H, these are the errors you would get. And if you can remember back to when we first did functions, these are the errors you got when you didn't declare your function before you used it. It's just the first thing it does, if it sees a function it doesn't know, it calls it something that returns an int. And then when it gets to the function somewhere, as it does, eventually it goes and finds the actual definition of the function, and it's incompatible with returning an int, so it starts yelling at you. So if you see that, know that you probably forgot an include somewhere. And so including standard I/O is one of the common things we do. There are dozens of other .h's that you can include, and as you get more and more into C, you'll find which ones you need to include when. For example, there's something called math.h, which defines what cosine and sine, absolute values, various other things like that are, which you probably don't need, but the engineers need. And there's ones, there's all kinds. And slowly you'll learn how to find which ones you need and which include file you need to use to make it all work. I will get to that sometime in the summer. Okay, so I think I already said this. Yeah. So the angle brackets are special, telling you to go look at the system place, or we can actually write our own .h's. So if we wanted to, remember the one we did where we had a function, and we declared the function before main? We could have actually taken that declaration, put it in its own file, blah.h, and we could have done #include blah.h with double quotes around blah.h, and it would have grabbed our include file and shoved it in there. But that's a bit much for only one declaration. If you've got a whole bunch, maybe it's worth it. But I won't do anything else. So okay, let's do some. This should look familiar. Tax practice and all. Appropriate.
I just filed yesterday.
Yeah, that's good.
This morning.
This morning. Yeah, my daughter, junior here, my wife just did her taxes. Yeah, that's $600. That's always bad.
Oh, and I know.
That's good.
0% tax. Something close to it anyway.
Every little bit helps me.
Yeah, I mean practically nothing. So I don't think I have any errors in here yet. I promised I'd start putting errors in, but I didn't.
I'm sure I'll make enough on my own. I'm trying to.
So there's some oddities here that you haven't seen before. Can't remember how it runs. Yes.
I did, I keep it right out with it.
Yeah.
Yep.
And that's
For
exactly
whenever,
what it
yeah, I'm
says,
like, oh,
doesn't it?
I got that. Doing something with So how do you get tax bracket? We're supposed to.
Yeah, I guess it would be worth thinking.
Yeah.
So, you'll notice, see this, cover the range without any hole. I hadn't used these equal guys here. We have holes. How we doing? All right, halfway through tax bracket. All the way through tax bracket. Running. Oh, I think. Yeah. No.
Oh,
See, if you look at this, yeah, it's actually done. It gave you a prompt. I didn't do a multiple one on this because it didn't seem worth it. You already knew how to do that, so just the function call. And all its details.
told me not to.
So, any questions?
The married and single.
Yeah, good stuff.
You do that before it is made.
That's right. What the heck is
something
that?
that already exists?
All right. Let me explain that. That is the biggest change in this program compared to others. Remember I talked about the pre-processor. And all pre-processor things start with this pound sign business. So these defines up here are pre-processor commands. And what they do, too much about spacing.
Oh, no?
No.
Oh, I don't want to do that. Okay.
Now, spacing, some spacing matters, some spacing doesn't. This is just purely for looks. And there doesn't need to be any space here at all.
Except for
And that doesn't, we don't need space there. We do need a space there to separate it from the zero.
Do you have to not have a space between greater than?
No, those spaces are irrelevant.
No, not like
Which one?
between.
Which one?
Like, you have the greater than and then you define right next to it. So if you put a space between that,
Oh, right. Yes.
so you have
They
to
are
have
they are a symbol, so yeah.
Okay.
I'm not sure, but I think you're right. I don't think it would work if I had a space in between that.
I mean, I don't think you would.
Try it and see what happens. Just do one and try compiling, see what you get. I don't know all, but the compiler does. So I just asked the compiler a question. Did it work?
Nope, error.
Error.
Effective expression.
Yeah. Yeah. So, yeah, that's a symbol. No space. So how we doing?
What? I picked cool.
Compiling. All right. Almost there. So we have these strange things called married and single that we define using the preprocessor, and those are constants. Okay, let's figure this out, and we'll get to it. So what's it say? Line 2. Expected blah before blah. Compiling status is an underscore, not a dash. And there as well, underscore. You can't have periods or dashes in the variable name. Periods and dashes mean something else to the compiler, so it gets confused. It's compiled. And it's running. Alright, go ahead and run it once, and then we'll... I remember, 2,000, so the person is really, really rich. Okay.
Would you make?
Yeah, that would be nice. Alright, so these defines here. These define symbols. They're like variables, but they aren't. So these are actually constants that get replaced with these values when the preprocessor runs. So when the preprocessor is done with this file here, besides including all this standard IO.h stuff, these aren't here because they're preprocessor commands. And right here, it has a 2. And right here, it has a 1. It replaces those strings with that value when the preprocessor is done. You can think of it as when you're writing it, that you're defining these symbols to be these constants. But when the preprocessor gets around to it, it just replaces them. So it's like there's a number 2, a number 1 right there, and a number 2 right there. When the compiler sees it. But this makes your code more readable than if you just stick stupid numbers throughout the code. It means something, and we can understand that, but 1s and 0s and 2s and whatever the heck that doesn't mean. Sometimes you'll have multiple choices, maybe 5 or 6 that you want to be able to choose between. And just give them each a number, and then use the variables and use those symbols throughout your code, and then it makes sense. So this is a standard C thing that you do all the time when you have a choice between just a few possibilities. And so you use the find thing, and always do all this junk for your main program. That way it's easy for other people to find it, and it's easy for you to remember what the heck you did. And you just go look at the top of your file. Sometimes you can't remember, what happened to it that way? And you give it an hour or so, and you forgot it. Okay, so we changed this tax bracket code. You may remember the tax bracket code. It was just this before. And so we changed it to have, married or single filing status. And so we came up with this married or single variable, which is just an int. All it's got to hold is 1 or 2. And we pass it to tax bracket. So tax bracket knows if you're doing filing married or filing single. And it returns a different amount of tax depending on that. So you're sending it what your filing status is. And notice filing status here being passed married or single, the variable. So those have nothing to do with each other, remember. When you call tax bracket, it takes the value of this variable and it makes it the value of this variable. It's the value of that variable, makes it the value of that variable. So these names have nothing to do with each other. Absolutely nothing. Now, notice that this is an int, this is a double. So if we passed an int here, I don't think we need to compile. But even if it compiled, it would screw up because basically, an int and a double, you can't really do that. And it would screw up significantly. Remember, the order of the bits in an int and the order of the bits in a double, they're completely different. So all this does when it sends it to here is it copies all those bits to this guy. It doesn't care anything about what the heck you called it at that point. It just says, okay, we need the double, copy a byte from there and shove it here. So if you screw up these types, then your computer program is garbage. So always make sure these types match when you send stuff to a function. Yeah.
Okay, so because you declared married or single equals single up there,
Right.
Does that mean your function down there completely ignores the whole else part of the function?
Exactly. I mean, what it does is it says, okay, filing status is equal to 2, and it looks and sees, okay, is filing status equal to married? So no, married's 1, so no, it's not. So then it says, okay, I'm going to go do else. Exactly. Just like income whatever the heck it is, let's say it's 35, you know, and it'll go to this one, say, okay, it's greater than or equal to 20, it's less than 40, I'm going to return 0.15, and we're done.
Yeah, but that's different because when your program's running, you physically type in your income.
That's right,
You
that's
don't-
right.
you
And
have
this
to go
is
in the
pretty
code
much,
to do
this is
that.
hard-coded.
Yeah.
I just had you read in one thing instead of
I mean,
two.
that's why I was just...
Normally, you know, you're going to be reading in this as well as the salary, but I didn't want to go there. That's why we keep it simple. So, you know, you could have a spreadsheet that had two columns, and the first one was what your filing status was, and the next one is your income. And you could write this to read in both those columns, and then send it to tax bracket. You wouldn't have to rewrite tax bracket to do that. Tax bracket would still work, assuming that your file had 1s and 2s, which it probably doesn't. The spreadsheets or whatever they are, right? And you have to kind of convert. So part of what you do with programs, a lot of what you do with programs is you do conversions like that. Let's say you had a spreadsheet that actually had married or single string in the column. So then you'd have to read in that column as a string, and then write another function, and okay, it's this string making a 1, it's this string making a 2, and return that, and then you can call tax bracket. So a lot of what you do in programming is dealing with that crap, because everybody decides how to do it differently, and you have to do it. And of course, if you read in the string, you know, you could just rewrite tax bracket, so instead of using the integers, you use the string, which we haven't done yet. We haven't shown you how you can compare strings to other strings. But you can do something similar like this with strings. It's just like that. Looks like you're about to ask a question.
Yeah. With filing status, do you need those two equals? Would it run just one?
No.
No?
I mean, it would compile,
Yeah.
and it would do something stupid. It would set filing status equal to married. In this case, it queries whether filing status is the same as married. If 1 equals, it'll just do an assignment.
Oh.
And it'll let you, which is really dumb,
Yeah, that's
it'll let you do an assignment inside an if. Now, there are ways that can be useful, but not in this case.
Yeah.
In this case, it's just useless, right? It compiles because it's a valid statement, and because, believe it or not, if you do an assignment, this assignment actually has a value, which is 1.
Yeah.
You know, it succeeds. So the if will always succeed if you have 1 equals in here, and it will do really stupid stuff, and you won't be able to figure it out. So be very careful. Double equals is querying whether two things are equal. And a single equals is just an assignment. Any other questions? Okay, so if you were writing this, would you have done an else, or would you have done another if, and said filing status equals single? For
Seems
example.
like it's single. Instead of an L. It just seems like you need
So
to
how about you?
state
Would
both
you
of
have done
them.
that? Would you have done a end if here, and then start another if with if filing status equals single? It is less typing.
And
Not
there's
to
only one
mention-
other option.
Not to mention that no matter what, one of these will actually get run. If you do the two ifs, you may screw up, right? And then none of them will run, because maybe you're somehow married or single is equal to 3. Somehow, something stupid, right? So, you got to assume when you write a code, you know, write a function like this, you got to assume that the people that are using it are stupid. Even though they're you. You got to assume they're stupid. You got to assume that they can't remember how to use your code. And so, very often, you have to check to make sure that they're using it correctly. Make sure that filing status is equal to 1 or it's equal to 2 before you even do anything. Now, I didn't do that here, but it's a very common thing with everything you write to make sure that they're not using it in a stupid way. Like, for instance, I didn't check if income was negative, which is stupid. But if they give me a negative income, I'm always going to be returning 0, right? And perhaps that's not what they intended.
Because
So
it's technically less than 20.
it is technically less
Even
than
if
20,
it's
exactly.
negative 10,000.
It is. It's less than 20. But, maybe they somehow screwed up and they doing some calculations, they got negative instead of positive, and I meant to do an absolute value and I forgot. So, very often, the right code that actually works, especially when you only do it occasionally, checking that everything that you're getting in is what you expect. It's a very good thing to do. And I didn't do it because it makes this thing even longer. But it's a good thing to do. So, yeah, it runs. And define stuff is a way to do constant. And remember, it's preprocessor, it's not C. So C doesn't even see this. So before this one, we've done functions that had one argument instead of two, like this. So I purposely chose this to have two, and have them be different types, so that you could see what it looks like to have two and to have different types. These could have been the other way around, when you had double income and then you had filing status. And if the person using your code gave you stuff in the wrong order, you got total garbage, right? Let's say they called it. And they called it and they gave you income instead of filing status for the first one. So in filing status, you get the value of income. It's a double. This is an int. You're going to get garbage. I'm not sure it'll even compile. Probably won't. Probably won't compile. But in some languages, that happens a lot. It lets you get away with that, and it gives you total garbage. So once you have more than one, you got to make sure they're in the right order, because the compiler doesn't really know what that is. Let's say they were both in, just for the fun of it. The compiler wouldn't know and wouldn't care if you had it in the wrong order, because they're both in. And as long as you give it two ints, it's happy. But if they mean something completely different, you're going to be in trouble. Okay, so remember, those functions, these names here can be anything, and they have nothing to do with the way you call it. So you could call it with this, just numbers, and there's no variables involved at all. The reason I harp on this is that a lot of people that came in for Engine 101 made their variable names the same from the caller and the function, and they think that meant something, and it has no meaning at all. It's irrelevant. It's even confusing. So don't ever do it. The names need to be completely different, just to remind yourself. And so, in this case, there's no variables at all, right? This is just numbers. These are just constants that get assigned to those variables when you call it. Almost as if it's doing an equals for you, right? Setting that variable name equal to whatever this value is. And so it doesn't really matter what's called in the main, called in the function. Okay, so how much time we got?
1 minute.
1 minute. All right. Well, we didn't get to exercise. But I know you're dying to do this for homework.
Oh, definitely.
I went on and on too much about such things. But,
Well, sometimes it's necessary to go on and on because it
yeah.
explains more.
So, yeah. That whole thing about how values get passed to the function is extremely important. And next time we're going to actually talk about strings. Strings. you've used strings a lot already,
Hmm.
and you got these things to double quote.
Yep.
But strings can be variable too. Those strings you've used so far are constant. Just like these guys are constant, right? And we also have variables, so strings. And declaring them is a little bit different. And using them is a little bit different than what we used to do. Okay.
So I only have 2 or 3 weeks.
Ah.
I'm
So we'll
leaving-
have to do this every day.
I'm leaving for Utah in 3 weeks.
And you'll never come back.
I mean, I'll be back eventually, but
So,
Utah, you home? Huh? Utah's your home?
no,
no.
I'm from here.
Oh.
But I'm going out there to try out for a job.
Oh, good luck to you.
Try it out.
Yeah, it's a wilderness adventure repair.
Oh my God.
So we like to take kids out in the wild and like teach them how to swim and dive on. And I had told them that when they like me, want me to come out and then but we'll try out my 11th tonight.
You gotta prove yourself.
So I'm driving out there, buying all this gear, driving out there.
All for free, basically.
Yeah, quitting all my jobs, driving
Yeah.
out there, trying out this job. And if I get it, I'm staying. But
And
if
if
I
you
don't,
don't-
I'm staying anyways. I'm gonna just be out west with a bunch of
You know.
gear. So,
Get help with other jobs.
yeah.
Yeah.
And I run out of money and then get another job.
Alright.
It sounds adventurous.
Yeah.
And free.
Well,
If I was young,
hopefully-
I would say to do that.
Yeah, see, I know.
Before you get married, just say.
Exactly.
Hopefully this gives you the confidence to go on to one of the online things and finish learning skiing all by
Yeah.
yourself.
Yeah, no, definitely, because there's a bunch of useful things to do. I love this program.
I mean, programming in general is,
Yeah, and especially now.
and at the very least, it'll save you dealing with stupid spreadsheets and stuff that you don't want.
Trust me, I didn't even like to feel like I got to go through this.
Yeah. Well, I hope. But we'll do strings, I've done things so far. We haven't done I.O. yet. So far, we've just done reading from the keyboard kind of stuff. Haven't done files yet. Only slightly different. But yeah, maybe see how to do that.
Yeah.
So I'll open up all the files.
That'd be nice, because I work with it.
Yeah, right now it's kind of useless.
Yeah, I'm like, I'm
User
like,
input. Yeah. But it's just another small tweak above getting it from the board.
Thanks, Ian.
Yep.
Thank you.